Hi everyone, welcome to my channel Total Concise Understanding Olympiads and J. Today I am back with another problem on the one question series of mathematics with the name replacing two numbers with their difference. So let's start with it. This is the problem statement. Suppose the positive integer n is odd. First A is a person, writes the number 1, 2, 3, 4 up to dot 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 2n, not n, it's 2n on the blackboard. Then he picks any two numbers a, b, erases them and write mod of a minus b. Prove that an odd number will remain at the end. It is a very standard problem, but I thought to take it in this series because it is a very important logic we must develop while solving these type of questions. So first of all, there are 2n numbers. I will just divide this. First, let's play the game once. I'm taking 1, 2, 3, 4, 5, 6, a short game. Always, while solving this type of problems where there is given some end, means we have to generalize everything. So, first let's take a specific value of n and do it. It will be a very good practice while solving this question because you will get to know where the methods by which the game is being completed. So, let's start with it. Fine. Now I'm just taking any two numbers randomly and keeping it with a difference. So 4 and 2 I have taken and I have written 2 here. Now let's just remove 3 and 6 and keep 3 there. Now let's remove 1 and 3. We have 2 here. Now let's remove 2 and 5. We have 3 here and 2 and 1 removed. We have 1 here. So we ended up in an odd number, 1 here and odd. Fine. So it's proof that for a means it's not proof as such, but we can see that it's happening. I'm just taking it randomly and I'm getting one. So now let's get into the generalize. So there are two n numbers. From this we can say n odd numbers and n even numbers. N even numbers, right? Just among two n numbers, there are always n odd numbers and even numbers. And this n is odd, we know. N is odd. Means n value is odd. So we have odd number of odd numbers. I hope you can understand my statement. And we have odd number of even numbers as well. While proving this type of question, one thing must come in our mind that we are using invariance here. Invariance means we have to find something that is not changing, the something that is constant in the entire process. If we find something, then it's all done. So let's try to find such a thing. First of all, what are the different cases we can see while picking up two numbers and writing mod of a minus b. Case 1, a odd, b odd. So the number we are putting, let's say x, it's even. I'm just keeping it in a tabular form. A, B. I'm writing here one thing. X, I hope it's not visible. Okay. X is what? X is mod of A minus B. Okay. So case 1 we have written, case 2. Case 2, odd, even. What will come? Even. Odd, sorry. Odd minus even is odd. So let's see what's there in case 3. Case 3 is even, even, even. So just see one thing. What color to use? Is it visible? Yeah. Just see one thing. number of odd numbers. In case 1, what is it? Decreases by 2. In case 2, remains constant. In case 3, remains constant. Is it fine? We are removing two numbers and giving a even number. So two numbers are removed, so decrease number of odd numbers decreases by 2. We are removing one number, adding one number, so remains constant. We are not doing anything, remains constant. Fine. So what we can see is that the number of odd numbers is either decreasing by 2 or remains constant. What does this imply? This implies one thing, which I am writing here. This implies that parity. Parity means odd or even. Parity of the number of odd numbers is invariant. Parity of the number of odd numbers is invariant. So, since parity is invariant, number of odd numbers will always be odd, which was initially given. We were given number of odd numbers is odd, you can see. So according to that, the final number of odd numbers is odd. So what is the least odd number? 1. Least odd number is 1. So we will always be remaining one odd number at least, because there can be minus 1 numbers, because n is always a natural number, it's positive integer. You can see here. So the least odd number is 1, and so there will at least be one odd number at the end. And this proves our statement. Just for logical satisfaction, I am just saying another thing regarding the same fact, that even numbers, number of even numbers, you can see it is nothing is invariant in this. Case 1 increases by 1, case 2 decreases by 1, case 3 decreases by 1. We can easily see that this is nothing invariant in this number of even numbers. So means we can pull down number of even numbers from any value of n to 0. Like we have number of even numbers 5. After some statement, after something it became 4. Then sometime it increasing, then again 5, then 4, then 3, then again I think 4, then 3, then 2. Somehow we can get then 1, then 0. Somehow we can get to 0 very easily. But let's say the number of odd numbers were 5. So we can't get to 0 anyhow, because if 5 is present, it might decrease by 2 or remains constant. If it is remains constant, then nothing happening. If it is decreasing by 2, then 5, then 3, then 1, and nothing can happen. I hope I am clear with my statement. And so with this, I think it's the end of this video. Thank you so very much for watching the video till the end.